In this video I want to show you how to calculate molar mass for different compounds and different elements. So what is molar mass? The molar mass of a substance is the mass of grams of 1 mole of a compound. Traditionally the term molecular weight has been used. So when you see molecular weight, this term is equivalent to molar mass. Sometimes called formula weight or formula mass. So these terms are, all of them are equal. So the mole of methane CH4 molecules contain 1 mole of carbon atoms and 1 mole of carbon atoms and 4 moles hydrogen atoms. So when we want to calculate molar mass, here we have CH4, we have 1 carbon here and 4 hydrogen. So it means that in 1 mole of methane we have 1 mole of carbon and we have 4 moles of hydrogen. So what is the mass of 1 mole of carbon? It's going to be 12.01 grams, which is the atomic mass of carbon, which we can read it from periodic table. Next one is hydrogen. Hydrogen, as we know, the atomic mass of hydrogen is 1.008. So 4 times 1.008 grams. So in total, the mass of 1 mole of methane is going to be 16.04 grams. So that's the molecular weight of methane. So mass of 1 mole of methane is going to be 16.04. Let's have another example. A dijugalone has C10H6O3 chemical formula. Calculate the molar mass or molecular weight of this dye and how many moles of a 1.56 times 10 power minus 2 gram sample of this dye does have. So let's calculate the molar mass first. So that's the chemical formula. We have 10 carbons, 6 hydrogen atoms and 3 oxygen atoms. So we have in 1 mole of this dye we have 10 moles of carbon, 6 moles of hydrogen and 3 moles of oxygen. So 10 times 12.01 is going to be 120.1. For hydrogen it's going to be 6 times atomic mass, which is 1.08 grams, so it's going to be 6.048 grams. For oxygen we have 3 times 16, so we have 48. So if we add all these 3 numbers, we're going to get the molar mass. So mass of 1 mole of this dye is 174.1. In the second part of this example, we need to know in this mass of dye how many moles we have. So we know this mass is going to give us 1 mole. So let's see this amount of sample contains how many moles. So we have 1.56 times 10 power minus 2 grams. We know the molecular weight, which is 1 mole of jugalone is equivalent to 174.1 grams. So we cancel these two, and the remaining part is going to be number of moles. So we have 8.96 times 10 power minus 5. Next example, calculate the molar mass or molecular weight of calcium carbonate. A certain sample of calcium carbonate contains 4.86 moles. What is the mass in grams of this sample, and what is the mass of the carbonate ion present in this sample? So let's do the first part first. So calcium carbonate, we have calcium and carbonate. So 1 mole of calcium carbonate has 1 calcium and 1 carbonate ion. So the atomic mass of calcium is 40.08. So we have only 1, so it's going to be 40.08 grams. And the carbonate part has 1 carbon and 3 oxygen. So 1 times 12.01 grams, 3 times 16, so 12.01 grams, 48 grams. So if we add these two plus this one, is going to give us 100.09 grams. So that's the molar mass of calcium carbonate. So we said for the second part we need to know what's the mass of this sample. It has 4.86 moles. So 4.86 moles, we know the molecular weight or molar mass. 1 mole of calcium carbonate has 100.09 grams. So these two cancel each other, and the remaining is going to be mass of sample, which is 486 grams. And then we said, what is the mass of the carbonate ion present? So the molar mass of carbonate itself, it has 1 carbon and 3 oxygen. So if we calculate it, it's going to be 60.01 grams. So this one, 4.86 moles carbonate we have in the sample, and we have the molar mass or molecular weight of carbonate part. So these two cancel each other, and the mass becomes 292 grams carbonate. Next example, isopentyl acetate C7H14O2. Bees release about 1 microgram of this compound when they sting. How many molecules of isopentyl acetate are released in a typical bee sting? How many atoms of carbon are present? So let's do the molar mass first. We have 7 carbon, 14 hydrogen, and 2 oxygen. So 7 times 12.01, 14 times 1.08, 2 times 16. So these are all atomic masses. So the answer would be 84.07 grams, 14.11 grams, 32 grams. So after we add all of them, the molecular weight of this compound is going to be 130.18 grams. So it says we need to find the number of moles in this sample. We have 1 microgram, and after that we need to know how many molecules this sample has. So let's start with this one. 1 micrograms equivalent to 1 times 10 power minus 6 grams of this compound. So, and we know 1 mole of this compound is equal to 130.18 grams. So these two cancel each other, and the number of moles will be 8 times 10 power minus 9 moles. That's the number of moles in that sample that has 1 micrograms. Now we have a number of moles, we can find the number of molecules. So here we write the number of moles. We know in 1 mole of any compound or any element, we have 6.022 times 10 power 23 molecules. Or for elements, we have atoms. That's the Avogadro number. So these two cancel each other, and the remaining part would be the number of molecules. So we have 5 times 10 power 15. So that's the total number of molecules in 1 microgram of this sample. And then we said how many atoms of carbon present in this sample. So we have this number of molecules in this sample, and each molecule contains 7 carbon atoms based on the formula. So these two cancel each other.